say, what we're going to do is today is I'm going to try to combine 3 lessons into 2. We didn't have a lesson yesterday, so we need to actually catch up with quite a bit of work. We're going to look at arithmetic sequence. Now, in terms of arithmetic sequence, of course, we're going to look at geometric sequence as well. You need to know that there is a recursive rule, and I'm going to introduce a new term, explicit rule or general rule. All right? We'll talk about it a little bit more. Now, you should know what a recursive rule is. We talked about it last few lessons. We know there's a rule, and we know you have to specify the first term. Correct? So, for today, what I would like all of you to know after the end of the lesson is understand that an arithmetic sequence is a sequence with a common difference between the terms. You should be able to derive a recursive term for an arithmetic sequence, derive an explicit rule or a general rule for an arithmetic sequence. Find the nth term of an arithmetic sequence, and given 2 terms of an arithmetic sequence, find a common difference, first term, and then the rule. Alright? Now, let's have a look at this. Just a quick memory jogger. You know for A and C, you are looking at, for example, A is add 3 to the previous number. Alright? C is subtract 5 from the previous number. Whereas B is slightly different, doubling the previous number. Now the focus question here now is, what make A and C arithmetic sequence? Why? Why is A and C arithmetic sequence, whereas B is not? Is there ready yet?
Because they go up by a common difference.
Very good. So they go up by a common difference. So there is a fixed number between A and B. So A and C. So A, every number, you add 3. Harold, how are you? Good. All right. I'm not sure whether my my iPad is working properly, so I'm going to use the board. So every number here is plus 3, whereas this one is minus 5. Correct? Yeah?
Yes.
So if you know that, that is actually called the common difference. The common difference. So, arithmetic sequence, let's define it. An arithmetic sequence is a sequence of numbers such that the difference between any 2 consecutive numbers of the sequence is constant. The word constant is important. It must always be constant. Exactly the same number. Alright? Now, an arithmetic sequence is also known as an arithmetic progression. So those are the 2 terms you need to know. If you could write it down, please. Arithmetic sequence is the same as arithmetic progression. It's interchangeable in an exam or test. And the common difference, the constant, the difference between the constant is the common difference. All right? So those are the terms that you need to know. And finally, last but not the least, an arithmetic sequence, all the graphs are linear. It's not exponential, it's not nonlinear. So think about arithmetic sequence. It's a linear graph, and you can sort of link it to y equals mx plus c. I will explain to you a little bit later what m is. Alright? So know the common difference, and the common difference is always a constant. All right, let's move on. Now, so here I've shown you what the sequence was, the one I showed you a few minutes ago, which is an addition of 3. Correct? So from T1 to T2, you add 3, add 3, add 3. All right? Now, when you plot a graph of arithmetic sequence, it is always discrete and it always must show a dot. That's all. You're not going to use a line to connect it. I'm actually now drawing a line just to show it to you that it is a straight line. So always make sure that when you draw in the exam or test plotting it, it has to be just a single dot. All right? And the y-axis is always Tn, and then x-axis is always n. All right? Now you can link these two, Tn as y and n as x. All right? If you think about the conventional, when we are the traditional, when we use y equals to mx plus c. All right? I want you to think about that. Tn is the y-axis, n is the x-axis. Now, let's have a look at the example. From the list of the 5 sequences below, can you identify the sequences that are arithmetic sequence? All right, go ahead and do it. All you need to do is identify. I don't want you to come up with recurrence rule or anything at all. Just think about whether they are arithmetic sequence. All right. Oops, what have I done? Here. So if you look at A, that is at, oh, it's not working. Let me sort it out. So that is actually, the difference is 20. The difference is 40. The difference is 80. So is that an arithmetic sequence? It is not. What about this? Plus 4. Yes. Plus 4, plus 4. So it is an arithmetic sequence. This one is minus 2, minus 2, minus 2. Arithmetic sequence. This is plus 2, plus 3, plus 4. So it's not arithmetic sequence. Now let's concentrate on E for a while. How are you going to work on E? Does it matter if it is in X or Y? No. So it's the same. Here, from here to here is plus 2, correct? From here to here, X plus 2 to X plus 4, again is plus 2 and plus 2. Agree? So therefore, that is an arithmetic sequence. Happy? All right, we'll move on to the next one. All right, so let's talk about arithmetic recursive rule. Let's consider this sequence. You should know how to write the recursive rule from last 2 lessons. Think about this. What you need to do is work out, look at the sequence, work out the pattern. You know that this is take away 5, take away 5, take away 5. So you know that this is a sequence and there's a common difference. It will go on and on and on. Every other number after this, it will be take away 5, take away 5, take away 5. So algebraically, what we can say is Tn plus 1 is equals to Tn minus 5 and T1 equals to 10. So think about it. You've got a rule. The rule here is the next number is the previous number, take away 5. And T1, the first term is 10. All right, this is how you should describe it. Think about it and how you should describe it. here, I've circled here, minus 5 is the common difference. And T1 is the first term, A. Therefore, come at the whiteboard here. When we have a recursive rule, Tn plus 1 is Tn plus D, the difference, and T1 equals to A. Always specify the first term. Alright? This will be in your formula sheet. Alright, this box is important. You must know that the recursive rule for an arithmetic sequence is given by Tn plus 1 equals to Tn plus D, where T1 equals to A. And D is a common difference, A is the first term. That's what you need to know. Alright? Write down the formula, please, and write down the definition of D and A. Thank you. Can I move on now? Alright, example 2. Look at this sequence. In your own words, can you describe this rule? And can you work out T2? And can you state the first 5 terms of this sequence? So when you describe rules, you can say starting with 19. The subsequent terms is the previous term, take away 2. Alright? If you're asked to describe, that's how you would do it. Always state what the starting is, which is 19 in this case, and then the common difference. The subsequent terms is the previous term, take away 2. So what is T2? T2 is therefore 19 minus 2, which is 17. First 5 term, 19, 17, 15, 13, and 11. Pretty straightforward in this sort of examples. You probably won't get something like this, that simple in a test. Alright, let's move on. Now, can you think about these 3 examples? Can you actually work out the recursive rule? At least do the first 2. We will discuss a bit more about C. Alright, you should be able to work on C as well. For me, the obvious way of doing is looking at something like this. Just use the sequence up there. Right? Once you work out the D, the difference, you know D is 2, you should be able to work out your recursive rule. Work out your D first. So in this case, the first one, Tn plus 1 equals to Tn plus 2. And you must always state T1 equals to 2. So in the test or exam itself, we will be looking at this will be worth 1 mark. Stating T1 will be worth another mark. Alright? This is how we look at the behavior. Behavior marking, we look at you are able to give the recursive rule as well as the first term. Next one, it should be Tn plus 1 equals to Tn minus 4. T1 therefore equals to minus 3. Do you all agree? Yeah? Next one is Tn plus 1 equals to Tn minus 5. And T1 is equals to y. There's no mystery about that. y is just a number. All right? So in this case, y can be any number. Are you all okay with that? Yeah? Yep. All right, let's move on. Now I'm going to look at using the last one, C, to derive the general rule or the explicit rule. All right? Now, with the recurrence rule, you always have to specify T1. Whereas with the explicit rule or the general rule, you do not have to specify T1. Now, look at this. What I've done is set it up in terms of a table and start looking at the difference. So if I've got T1 as y, T2 is y minus 5, T3 is y minus 10, T4 is y minus 15. I can write it out as y minus 5, which is d. All right? Here, 10 is y minus 5 minus 5. Yeah? Yeah? So therefore, it's y minus 2d. Correct? And then y minus 5, which is y minus 3d. So you keep on going until the end. You have Tn equals to y plus n minus 1d. Right? So if it is term 4, this is the first term plus 3 times the difference. If it is second term, it's first term plus 2 times the difference. Yeah? Got it? So therefore, I'm introducing the word explicit rule or the general rule. The explicit rule or the general rule for the nth term of an arithmetic sequence is Tn equals to a plus n minus 1d, where d is a common difference and a is the first term. Can you please write that down? You need to know that. All right, notice the difference between this and this. The recursive rule and the general rule. The general rule, you do not need to specify the first term. All you need to know is what n is, you substitute n into that term once you know your a and your d. All right? Whereas in this case, you must, for recursive rule, you must always state the first term or any other terms. Generally, we use first term. All right, let's look at some example. Can I move on? Yeah? Okay, let's look at some example. So now here, you need to determine the explicit rule for the following arithmetic sequence. Start off from the first one. You know that A is actually equals to 18. Correct? You know the difference is plus 4. Oops, I better write it better. Properly. You know A is equals to 18. The difference is plus 4. Yeah? Now, so therefore, you know Tn is therefore equals to A, which is 18, plus n minus 1 times d, which is 4. Alright? So remember, Tn equals to A plus n minus 1 times d. Alright? N can be any terms. So, now in the exam, especially based exam, I would suggest that you multiply that in and simplify the terms. So therefore, this becomes 18 plus 4n minus 4, which is 14 minus plus 4n. Right? Now, for Wei's exam, it hasn't been really consistent in terms of marking behavior. I have seen exam marking which accepted this, but I think 2/3 of the times they prefer you to expand. So please expand. All right, write this one down and then expand it. right, always expand it. Can you try the next two, please? First, find out what A is and find out the difference. Alright, in this case, A and B, they are the same 12. So therefore, nth term equals to 12 plus n minus 1 times 12, which is 12 plus 12n minus 12, which is 12n. Alright, now, just to prove my point, I'm going to use Tn equals to 12n as an example. Alright, so if n is 1, Tn is 12. If n is 2, Tn is 24. If n is 3, Tn is 36, and so on and so forth. Alright, that is actually the same as that, correct? Yeah? So you can see that what we're doing here, when we have a general rule, when you're given a general rule, all you need to do is substitute the n in. Then you can get your sequence. Here, the difference is minus 4, minus 4. So therefore, Tn equals to, and A is minus 3. Minus 3 plus n minus 1. Now, caution. Focus for a minute, please. Because the difference could be negative, could be positive, what I want all of you to do is to get into the habit of putting a bracket. Make that a note, because I have seen in the exam, so many people did this to me. Tn equals to minus 3 plus n minus 1 minus 4. And that ended up giving me minus 7 plus n minus 1 and giving minus 8 plus n, which is a completely different sequence, correct? Yeah? So please make sure that you put a bracket in, so when you multiply in, you know that this is minus 3 minus 4n plus 4, which means it becomes 1 minus 4n. Alright? Please, please, make a note of that. Those are the exam tips that I'm going to give you. Always use a bracket. I mean, I'm guilty of doing that as well without using a bracket. Strictly speaking, I should use a bracket so that I know what it is. Alright? Example 4. Can I go on to an example 5? So I'm going to give you as many examples as I can the next couple of days. And because I don't see you on Monday, I have given you a little bit more to do. Now here, another exam tips. In all assessments, if you are asked to determine a rule for a sequence, always state the explicit rule or general rule. Alright? There are so many questions in ways. What it says is, state the rule for the sequence. And they expect you to give general rule, not the recursive rule. Only write down the recursive rule if you're specifically asked. If not, general rule. Alright? Make that a note, please. That's an exam tip. So you can see as the year goes on, I'm going to give you exam tips so that you know what to do in the exam. get the marks. 2 things I've mentioned, always use a bracket. 3 things actually, expand, as well as always give an explicit or general rule in all assessments, unless they state that it's recursive rule that they want. Alright, move on. Now, we are getting into worded question, and I would like all of you to get your calculator out, please. Your class pad out. If you haven't got one, please come and grab one. You need to be able to use your class pad. Anyone? Anyone else? No. You've got your class pad. Good. Alright. Let's have a look at this question. The 12th term of an arithmetic sequence is 119. Yeah. If the sequence has a common difference of 4, determine the first term and then the 71st term. Wow. Alright. I'll show you how to do question A, and then you can try question B. So the 12th term, T12, is 119. Alright? If the sequence, let me highlight first. 12th term is 119. The sequence has common difference of 4. D equals to 4. Determine the first term and the 71st term. So how are you going to use it? Are you going to use your recursive rule, or are you going to use your general rule? Think about it, you should be using your general rule because you know Tn, you know D, and you know N. Yeah? Alright, so T12. So T12, 119 equals to A, we don't know A, this is first term, plus N in this case is 12 minus 1, and the difference is 4. Right? So you know Tn equals to A plus N minus 1 times D. Oops, not 4, D. Alright? Knowing Tn is 119, D is 4, and N is 12. Right? So therefore, solving that, 119 equals to A plus 44. So A is 119 minus 44, which is 75. Now, do you agree with me? Yeah? Now, the 71st term, use your class pad. I'm going to show you what to do with class pad. So, from here, because you're not asked to determine the equation for the general rule, you don't need to. What you can do is just substitute 119 equals to 75 plus N minus 1 into 4 into using your class pad. Alright, get your class pad out, please. Alright, with the class pad, go into your sequence. Alright? In sequence, what you need to do is clear everything, please. Edit, clear all. Make sure that you clear everything. This time, you are going to use the explicit rule. Tap on here. You've got your explicit rule now, instead of your recursive rule. So see the difference. You look at the screen. This one, when you look at your recursive rule, you have to specify whether it's A1 or A0. Yeah? Whereas for the explicit, you don't. You don't have to do that. You just have to input your N, which is here. So now we can just input this. 75 plus bracket N, which is, it is N minus 1 times 4. Alright? Just include that in. Or if you want to expand it, that's fine as well. Which is, if you expand it, that will be Tn, that's not 119, it's Tn equals to 75 plus 4n minus 4, which is 71 plus 4n. Alright, you can do that as well if you like. But if you're not asked, you're only asked to find the 71st term, just put that in. And then tap on that, same thing, you will get your 71st term. Now, 71, there. So T71 is minus 205. Alright? Pretty straightforward using your calculator. What was it? It's 205. So T part B.
You put the minus instead.
This is what? T71 is minus 205. Alright? This will be calculated assume, and you can just straight away write down T71 is minus 205.
So isn't it 355?
Sorry?
Is it 355?
Beg your pardon?
Isn't it 355?
Is it 355?
Yeah.
Have I done it incorrectly?
Put the minus in the class.
It's.
In the class pad, you did 75 or minus.
Did I do 75 minus is plus, is it?
Yeah.
Ah, yeah, sorry, it's my fault. My class pad I typed in incorrectly, it's plus. Oops.
So what is this one, man?
What did I do
Some-
minus?
You learn more about that.
You didn't know that.
Not now. Not now.
Yep,
Yeah.
my fault. So it is 355, correct. My fault. 355 is plus. 355. All right, the next one. Can you try that, please? The 52nd term of an arithmetic sequence is 77. If T1 is minus 25, determine the common difference and then the 15th term. All right, try that, please. You now know T52. You know N is 52. You know A, but you don't know what D is. All right. All right. Now, do you agree with me? D equals to 2. Yeah? So, I substituted Tn, T52. This is A, and this is N. All right? So, you can use your class pad to work out the 15th term. Or if this is the calculator free, you would know that T15 is equal to minus 25 plus 15 minus 1 times 2, which is minus 25 plus 14 times 2, which is minus 25 plus 28, which is 3. All right? B could potentially be a count-free question. All right? B could potentially be count-free. The examiners will expect you to know this sort of maths. All right? Any question before I go on to example 6? Everyone cool with this? All right, next example. Now, here, the explicit formula for an arithmetic sequence is Tn equals to 21 minus 2n, and determine the 100th term in this sequence. All right? What you need to do is think about what does 100 mean. You're just substituting n as 100. All right? So T100 equals to 21 minus 2 times 100, which is 21 minus 200, so therefore is minus 179. All right? Then how do you determine the recursive rule for this sequence? Use the information here. Use this information. You know recursive rule, you got to specify T1. All right? Yeah? So T1 is therefore 21 minus 2 times 1, which is 21 minus 2, which is 19. All right? Now, here, this bit here, it gives you T. All right? Since Tn equals to A plus n minus 1d. All right? So if I expand that, that is A plus dn minus d. Correct? And you know that A and d are just numbers. A is the initial, the first term, and d is the common difference. All right? So here, d is therefore minus 2. So writing the recursive rule, Tn plus 1 equals to Tn minus 2. T1 equals to 19. All right? You must know how to working backwards, how to work out what T1 is and how to work out the difference. Any issue with this before I move on? Hang in there. I might go up to question, example 9, and then we'll do 10 and 11 tomorrow. All right, we'll see how it goes. I know it's a lot to take in. Can I move on now? All right, let's go on to the next one. Example 7. Right. This is an interesting one. In an arithmetic sequence, Tn equals to 20 and T14 equals to 32. Determine the common difference and then state the T1 and then state the explicit rule and then determine T20. All right. What I'm going to do is get you to think about this in terms of a linear equation. So in terms of linear equation, y equals to mx plus c, you know that this is axis y, this axis is x, correct? Now, in our sequence, instead of y, we actually have tn. Instead of x, we actually have n. Correct? Yeah? So you know that this is 1, 2, 3, 4. This is T1. That is T2. Yep. T3 and so on and so forth. So now think about in relation to y equals to mx plus c. Alright? M here is actually the difference. Okay? M is actually the difference. So what we can do is to work this one out. Here, that is the y. This is the y2, this is the y1. Alright? And this is the x2, this is the x1. Alright? Is that clear? Yeah? All happy with that? So now with part A, what we can do is, what we're going to work out is the difference, which is the slope of a linear equation. How do you work out the slope? Right? So, it's 32. D is therefore equals to 32 minus 20 divided by 14 minus 8. Alright, that's the slope. Your y2 minus y1 over x2 minus x1. Alright? So use your Tn minus T14 minus T18 over the difference between the n. So therefore, you've got 14 minus 8, which is 6, 32 minus 20, which is 12, which will give me 2. Alright? So the difference is 2. Now you need to be able to work out T1. Alright? Part B. I'm going to use the main information of T8. So you know T8 is actually A plus 8 minus 1 times the difference. Correct? So T8 is 20 equals A plus 8 minus 1 is 7. 7 times 2 is 14. Correct? Yeah? That is 7 times 2. 7. This is 2. Alright? 14. So therefore, A is now 20 minus 14, which is 6. Alright, you have your D, you've got your A. Can you please state the explicit rule of this sequence? What is the explicit rule of this sequence? Or general rule? Use that and expand it, please. Alright? Do you all agree with me? Yeah? Alright. Again, I would say that this could be potentially calculator free. Quite a typical exam question, this one. So T20 will then be equals to 4 plus 2 times 20 equals to 4 plus 80, which is 96. Alright? I would say that something like this is potentially the first question of your test. Any question before I move on? All right. Example 8.
Sir.
This one is calculator assumed. All right. You need to know this sort of technique. For the arithmetic sequence 17, 21, 25, determine which term is equal to 305. You need to be able to use your calculator in this case. All right? The reason why I'm introducing this now is you are going to need all this, how solving something which is more straightforward in terms of your financial calculation a little bit later. All right? And a few of the modeling questions. So let's start. You know that the difference is plus 4. Correct? Yeah? So Tn plus 1 equals to Tn plus 4. And T1 equals to 17. Happy with that? Yeah? So we want to know T question mark equals 305. Alright, there are two ways of doing it. I'm going to show you the calculator way first. So Tn plus 1 equals to Tn plus 4, T1 equals to 17. Alright, in your class bag, grab your class bag please. This time, what you need to do is go to recursive rule. And again, make sure that you clear everything. Yeah, clear everything. Alright? From there, change it to A1. You know that this is An plus 4. And then A1 is 17. Tap on that and get the list out. So, what you need to do is keep going down until you see 305. If it is a calculator assume section, use your calculator. Now, you can see that T73 is 305. So when you answer the question, T73 equals to 305. So therefore, term 73 is equal to 305. Alright? Use your calculator. Now, if you don't use your calculator, you need to solve equation. So you know Tn equals to, you got to use your general rule if it's a calculator free section. Tn equals to A, which is 17, plus n minus 1 times 4. Alright? So you know T, you don't know that, you know 305 equals to 17 plus n minus 1 times 4, which is 17 plus 4n minus 4, which is 13 plus 4n. Alright, solving that, n is equal to 73. Alright, you must be able to solve some linear equation if this is in a calculator free section. Alright, one last example after this. Now again, this is a technique that you need to learn. Alright, I'll show you how to answer this question properly. So for arithmetic sequence 8, 5, 22, determine the term, which term of the sequence is the first to exceed 10,000. Alright, so you know that D is 7, A is equal to 8. Correct? Yeah? So write that down. Tn equals to 8 plus n minus 1 times 7. Agree? Now, use your calculator. This will be a calculator assumed. It will not be calculator free. Calculator assumed. Alright, let's go to your calculator. So if I write down, go to clear everything first. It's always good to clear everything. Alright? And go to explicit rule. use your explicit rule. 8 plus n minus 1 times the difference, which is 4. Alright? And let it go. Keep going down. Ooh, 100 is not enough. Sorry? Beg your pardon? Oh, 7, not 4. My fault. Thank you. Thanks, Ava. Alright, let's keep going. It's still not enough. 100 is still enough, not enough. So what you need to do is expand it to maybe 250. Alright? Click OK. It will calculate and keep going. Still not enough. Yeah?
Wouldn't it be better to do it like this way?
Yeah, but...
Okay.
Yeah, I know you can do that. Yeah, you can.
Because you know,
Keep
n
going.
has to be greater than 10.
That's too much.
You know, it's,
1500, maybe?
yeah, no, it's not right.
Yep. So, what you can do, look at your calculator, look at your class pad. The reason why I want to show you this is the technique you're going to use is in the exam, how you're going to answer it. So in the exam, when you answer a question like this is T1428 equals to 9997. T1429 equals to 10004. Alright? Here, list the two numbers, one before 10,000 and one after 10,000. Alright? Yeah? So if you list that, what you would say is term 1429 is the first term to exceed 10,000. Alright? Now, the reason, make sure that in the exam, you always write down one before and one after. Always provide the evidence. It's so important for you to provide the evidence. Whoever's marking it, know that you know how to use your calculator. Alright? Yes, you can use solve. Not a big problem. If you want to use solve, that's fine. But this is technique that I'm going to show you because eventually you have to use that. Alright? Some of the financial question you have to use that. Alright, I know that I've gone on quite a bit longer than I expected. I'm going to stop here.